So this is the first video of chapter 14 and 15. As you can see, it is on acids and bases. The first video I'm gonna throw a lot of information at you in terms of what is an acid, what is a base, a strong acid, strong base. So pause it, slow the video down if you need to to go through it a tad bit slower to get the notes down. I just want to get that all out there for you, and I know you can pause it, so that's why I'm going to go a little bit quicker in this video. So the first thing you got to ask is, what is an acid? And an acid is any ionic compound that donates a hydrogen in a reaction or when it dissolves. So a common acid you might be familiar with is citric acid, which is found in a lot of fruits. That's what gives the lemon or lime its sour taste. So here's an example of a reaction where you can see the hydrochloric acid, HCl, when it dissolves, it breaks up into H pluses and Cl minuses. So in this process, it is adding more H pluses to the water than what was previously there. Now a base is an ionic compound that donates a hydroxide ion. Now if you remember, hydroxide is the OH minus polyatomic ion. Or another definition of a base is a compound that will take away hydrogens from solution. So let me get my pen here. An acid is something that increases how many H pluses are in solution. A base is something that decreases how many H pluses are in solution. Or a base is something that adds OHs to solution. So a base is also something that increases the OH. So a base can be either or, this or this. Now, common base is, a lot of your cleaning products are basic, so like bleach would be considered a base. And then we'll get to the pH scale next video. You can see some common substances here and what their pH values are, and we'll look at that in more detail later. So acid-base reactions. The generic acid-base reaction is this, where you've got HA, so A is your anion that's attached to the H+, and then you got your cation that's attached to an OH group. When they react, the H and the B, you can say they switch spots. So the H is with the OH, which makes water, and then the B is going to be with the A there. So an actual example here is HCl plus NaOH. The H and the Na switch spots. So that's where the NaCl comes from. And then you can see the H is with OH, and remember HOH is just water. So you can see the red H comes from the acid, the purple OH comes from the base. A common acid-base reaction is done with a burette and a flask and phenolphthalein. We'll do labs with that. I believe we already have by the time you've seen this video anyways. So the indicator tells us when the acid-base reaction is done. This is called the picture here, this is called a titration. Okay, so what is the difference between a strong and a weak acid? So we'll go over strong acids right now. A strong acid is an ionic compound that completely dissociates in water. So what that means is no compounds are left over, you're only left with ions. So I'll show you an example here. Well, examples of strong acids, which you need, are right here. So HCl, HBr, HI, HNO3, all of these are your strong acids. If an acid is, if you look at a formula that starts with an H and it's not on this list, then it must be a weak acid. So you need to know these for the test. Make sure you know those for the test. These are all the strong acids that we know of, that we're going to deal with in this class. So if it's not on this list, it's not a strong acid. So what do we mean by completely dissociating in water? What we mean is that when you put this in water, this compound completely breaks up. There's none of it left over. It completely breaks up into H pluses and NO3 minuses. Or another way to write this is when you put it with water, all of the H's get sucked up by the water to form H3O pluses, hydronium ions, and nitrate ions. So there is none of the HNO3 left over. All of it breaks up into this and this. Now these two formulas here, the H plus and the H3O plus, you can pretty much think of them as the same thing. So I'm not going to get into the detail of why we look at one or the other, but for all intent and purposes, they are the same in this class. So here's a little visual to show you. If I put nitric acid into a solution of water, or into water, so I dump it in there. Let's pretend like I'm dumping in HNO3 into that water. All of the HNO3s break up. There's no HNO3s left. So you'll notice there's no HNO3s left in the beaker. All of the HNO3s have broken up into their ions. Now a strong base, same thing. It's an ionic compound where all the OH minuses completely break off when you put it in water. So examples of your strong bases are NaOH, KOH, and you can read the rest of the list. Now you'll notice that Na, K, Li, Fr, Cs, these are all alkali metals. Alkali metals. Sorry, that was terrible writing there. And then these are all your alkaline earth metals. So your strong bases come from the first two groups of the periodic table, group 1 and group 2. So instead of memorizing this, just know that group 1 and group 2, when they react with the OH, sorry, this one would also be an alkali metal, not an alkaline earth. I'll correct myself there. When you have any of those metals in the first two groups with OH, it's a strong base. When you put any of these in water, they completely break up. So here's an example, KOH. It completely separates into these two ions in water. So you won't have any of this in the water anymore. It'll all break up into this. So 100% dissociation is what we mean. So here's our example. I put KOH in water, and it all breaks up. There's no KOH left over. A weak acid, on the other hand, only partially dissociates in water. So there are compounds left over, the initial compounds. So here's some examples. This is not a complete list. These are just some examples of weak acids. So what we have here is some of this compound. When I put this in water, only some of it breaks up into its ions, and some of it doesn't. So you might have, only 5% of this actually breaks up, and 95%, it's still dissolved in water, but it's not separated into its ions. So here's an example. If I put acetic acid in water, notice I have 3 acetic acid compounds. Only one of them actually broke up, and the other 2 haven't. So it only partially dissociates or partially breaks up in water. That's the difference between a strong acid and a weak acid. Now a weak base is very similar. It only partially accepts hydrogens. So it takes H plus away from an acid, or it can release OH, but it doesn't completely dissociate. So here's some examples of weak bases. You'll notice here, though, magnesium is actually in the second group. That one is an exception to that rule on the from the previous slide. Okay, so an example here, you got NH3. It reacts with H2O, and it steals a hydrogen from the water. So now it's NH4 with a plus charge. It's ammonium. That's a polyatomic on our yellow sheet. And then we're left with an OH. So notice it increased the amount of OH in water. That is the definition of a base. But this is still a weak base. Okay, some properties. Let's quick finish this, and that'll be the end of this video. Acids, they have a sour taste. So here's a nice little video demonstrating the sour taste of acids. This would be citric acid. They also react with metal to form hydrogen gas. So here's an example of hydrochloric acid with magnesium. You can see it's giving off hydrogen gas. And the formulas start with an H. We already know that back from chapter 8 when we were figuring out the types of reactions. Now bases, they have a bitter taste. They taste very bitter, and they feel slippery. So an example is, I guess, soap. It feels like soap. So if you get a little bit of like NaOH on your hands, and as you're washing it off, it'll feel kind of slimy, almost like you have a film of soap on your hands. That's how you know that you probably spilled a base on your hands. So again, you just use soap and water, wash it off. But if you ever spill something on your hands, you get that soapy feel, that means you probably spilled a base on your hands. And they tend to react with metal ions to form precipitates. So here's a copper solution, adding NaOH to it to form copper hydroxide. So that's your metal hydroxide precipitate. And again, we already know this, bases tend to end in OH, the formulas do. And that is all the properties that you need to know at this point about acids and bases. So make sure you know the difference between a strong acid and a weak acid. Make sure you know the difference between a strong base and a weak base. Make sure you know how to write out an acid neutralization reaction. Study those strong acids. Make sure you can memorize those. And yeah, just know the definition between an acid and a base. That's the main takeaways from this video. We'll talk about the pH scale in the next video.